Hi, welcome to Mathmaxtra. This is Saritha. Today our topic is 9-point center. We have seen in the last videos different type of centers and this is the last center we are going to discuss. Okay, so this is 9-point center in which a circle pass through 9 points. So what are those 9 points? See, to take one triangle. Okay, so this is a triangle ABC. So first we have to consider feet of the altitudes. You draw 3 altitudes in this triangle and the feet of the altitude we are considering 3 points. So we have 3 altitudes, right? So we have 3 feet of the altitudes. See, let us consider, and this is one altitude, feet of the altitude D, and this is E, and this is F. So I'm considering 3 points as the feet of the altitudes. Okay, and you consider, yes, and we take the 3 midpoints of the sides. Okay, so let us consider this is a midpoint of BC. So this is P and this is Q and this is R. Okay, so these 3 points are midpoints of the sides. Okay, and you consider one 3 more points. Those are, if you let us consider the orthocenter be here. Okay, so from this orthocenter, if you draw a line to the vertex. Okay, so this is a segment drawing from orthocenter to the vertex. Okay, so this midpoint I am considering. Okay, so from the orthocenter you draw 3 segments from orthocenter to all the vertices. Okay, that is, so somewhere here this is the midpoint of this line segment and this is the midpoint of, if you draw a line segment from orthocenter to this, and this is the midpoint. Okay, now so now count the points. How many points we have considered? 9 points. See, first 3 points are feet of the altitudes. Okay, and the other 3 points are midpoints of the sides, and 3 more points are the midpoint of the segment joining from orthocenter to the vertex. Okay, so these 9 points, through these 9 points, one circle is passing through all these 9 points. Okay, so this is the circle passing through all these 9 points. Okay, X, Y and Z. Okay, so through these 9 points a circle passing through. Okay, so this circle we call it as a 9-point circle. Okay, and the center of this circle is called 9-point circle center. Okay, so that we represent always with capital N. N is for 9-point circle center. Okay, so this is how we can define a 9-point circle. Okay, and this is the, from the center to any point on this circle we call it as a radius of 9-point circle. So how can we define this radius of the 9-point circle? So which is simply is equal to capital R by 2. What capital R represents? Capital R is nothing but circumradius, right? So which is nothing but circumradius by 2. So this is the 9-point circle center radius. So how can we define a 9-point circle radius? Is simply half of the circumradius. Okay, so we will see some different properties related to all the centers. Okay, first I am considering an equilateral triangle. So we'll see what are the location of all the centers in the case of equilateral triangle. So now first I am considering an equilateral triangle. Okay, This is an equilateral triangle, okay, in which all the sides are equal, all the angles are also equal. Okay, this is an equilateral triangle. In case of equilateral triangle, so if you locate all the centers in this triangle, all the centers are coincide. See, if this is a centroid and this is also a circumcenter, this is also a incenter, this is also a 9-point center. Okay, so in this way, if you consider an equilateral triangle, all the centers coincide with each other. Okay, this is possible only in case of equilateral triangle. Okay, if you consider other than this triangle, these centers are different arrangement. Okay, we'll see how will they arrange in case of scalene triangle. Okay, so if you consider a scalene triangle, how will all the centers locate? So they all the centers locate on a same straight line, means they all the centers are collinear in case of scalene triangle. See, if you consider, so like this, all the centers are lying like this. Okay. O N G S. So in case of scalene triangle, all the centers are lying on a same straight line and means they are collinear. So this line we call it as a Euler's line. So what we call this line? This line we call it as a Euler's line. Okay, so now we'll see in what ratio they arrange in a collinear format. See, if you consider a line, this is a Euler line. Okay, so always orthocenter and circumcenter are at the end of this line. Okay, and the midpoint of this Euler's line is always a 9-point center. Okay, so the midpoint of all these this Euler's line is 9-point center. Okay, and this is a centroid. So we'll see what is the ratio of this. So they always arrange in the ratio of ON is to NG is to GS, which is equal to 3 is to 1 is to 2. So this is 3 points, this is 1 part, and this is 2 parts. So 3 parts, 1 part, 2 parts. So in this ratio, these centers arrange in scalene triangle. Okay. No. So we have seen that this 9-point center is always a midpoint of the line segment joining orthocenter and circumcenter. Okay. So if you consider the OG is to GS ratio, OG is to GS ratio. So what is the OG is to GS ratio? From O to G, 4 parts are there. So 4 is to GS is 2 parts, which is nothing but 2 is to 1, right? So that is why we call this G point as a trisection point. Means this divide this line segment in the either 2 is to 1 ratio or 1 is to 2 ratio, means which is nothing but a trisection point. So G we call it as a trisection point. Okay. And this N is called midpoint of this line segment joining orthocenter and circumcenter. So this ratio we have to remember. So while solving the problem, this will help you. Okay. Now you consider an isosceles triangle. So this is an isosceles triangle. In this isosceles triangle, so all the centers are collinear. They are lying on the line from, so in the isosceles triangle, this we call it as a base. Okay, some from vertex to the base, if you draw an altitude and if you draw a median, if you draw a perpendicular bisector, all will coincide and they are nothing but like this from vertex to the opposite side, and this is only the median. and this is only the angular bisector, and this is only the perpendicular bisector. So all will coincide. Okay, they are equal. This is only the median. This is only the angular bisector. This is only the perpendicular bisector. This property is important in case of isosceles triangle. Okay, and so all the centers are lie on this line segment only. So all the centers are lie on this line segment only in case of isosceles triangle. Okay, and we have one more property, that is, if you take a triangle, in this triangle you draw an altitude and angular bisector. So will they coincide? That depends on the type of triangle. I didn't mention whether this triangle is equilateral or isosceles or scalene triangle. So we can't say whether the altitude and angular bisectors coincide or not. So I don't know which type of triangle it is. So I am simply drawing, okay, this is an altitude, okay, which is perpendicular drawn from the vertex to the opposite side. Okay, so this is an altitude, and now if this is a complete angle, I am drawing an angular bisector. Okay, so this is an angular bisector. Okay, so this is an angular bisector of this from vertex A. So what happens in case of different triangle? Always there is a chance of forming an angle between the altitude and angular bisector. Okay, so this is an altitude and this is an angular bisector. So there is a chance of having an angle between the altitude and angular bisector. Sometimes we need to calculate this theta. So what is the relation? So this theta we can define as these angles are base angles of a triangle. Okay, so we define this theta as a angle B minus angle C by 2. So if you know these two angles, you can simply calculate the angle between the altitude and angle bisector. So this is the relation between those two. Okay. We have one property in the similar triangles. What is that? So as we have learned about median, altitude and all these things, so now we can define that property. In the case of similar triangles, all the we have seen that the corresponding sides are in the proportion. Okay, the corresponding sides are in the proportion. Similarly, so we can define, so in case of similar triangles, the corresponding medians and the corresponding angular bisectors and the corresponding altitudes and perimeters of the triangles are always in the ratio of their corresponding sides, or in the ratio of their corresponding sides. And areas are in the ratio of corresponding their ratio of the square of their corresponding sides. Okay, which is nothing but if sides are AB and PQ, this is the if this is the ratio of the corresponding sides, then what is the areas ratio? Areas are always in the ratio of square of the sides. Okay, so they are in the ratio of the square of their corresponding sides. So this is the areas are on in this ratio. So these are the some different types of properties in case of similar triangles. So by this we have finished the topic of triangles. In the next video onwards, we will discuss about quadrilaterals. Okay, thank you.